Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. So we have been covering the topic time series in which we have completed the measurement of seasonal variations. In today's lecture, we'll start with another components measurement which is cyclical variations. So as we all know that, uh, okay, let us write first measurement of cyclical variation. So we have found out trend and then seasonal component. Now we are only left. Our model only has cyclical variation and random component. So our original model was YT. If we take multiplicative model, it was trend into seasonal into cyclical into random component. And but after finding out trend, we eliminated this, means we divided it by trend, and we got seasonal into cyclical into random component. Now the third step was to find out seasonal and to eliminate that, that is to divide with that. So we are only left with cyclical and random. Now here we'll find cyclical variation, and then we'll divide this yt. This would be yt star. This would be yt double star, and this would be yt triple star equals to yt double star divided by cyclical. Here we'll only be left with random component, and in the fourth time, where yt4 star is equals to yt triple star divided by random component, and hence our time series data uh, or the function of the time series yt is independent of all the variations or all the components, and this would be our final answer. So this is the process that we are following. So starting with cyclical variation, there is a method known as harmonic analysis. Now this is a little bit uh, explanatory part, or we can say that this is a little bit complex portion of time series. Till now it has been easier, but here we have to mug up some things, and we have to understand some things. So the concept of your sine, cos, and your trigonometric ratios should be good for this harmonic analysis. And harmonic analysis is the method which is also meant to find periodogram, which is also useful for periodogram analysis. So let us begin with harmonic analysis. It is a sophisticated method, means complex, sophisticated method to find cyclical component. So for this, let yt function of time series be represented under general circumstances into Fourier series. Now Fourier series is a very much known term. If you don't know this, then I am telling you Fourier series when a function can be represented as the sum of sine and cosines. So any series which can be represented as the sum of sine and cosines is known as Fourier series. So our original so our yt can be represented as a naught plus a1 sine 2 pi by lambda into t plus a2 sine 2 pi by lambda into 2t up till, and then the cosine series would be b1 cos 2 pi by lambda t plus b2 cos 2 pi by lambda into 2t up till nth terms. So this would be our function of the time series, which is also the Fourier series, which can be written as the sum of sines and cosines respectively. Lambda here is any constant. A constant is termed as lambda. So a naught is nothing but 1 upon n summation t goes from 1 to n yt. Ai, small ai is nothing but 1 upon n summation t goes from 1 to n sine 2 pi by lambda into t, and bt, sorry these are t, this is t not I. So bt is nothing but 1 upon n summation t goes from 1 to n cos 2 pi by lambda into t. So these are the three variables which we considered before. Here these will be 2 by n, and summation also includes yt, it, it. So these will be the 3 points that we did. So let us consider a time series where trends and seasonal analysis has been eliminated, and we have to find just we are only left with cyclical and random component. So yt can be written as a sine 2 pi by lambda into t plus epsilon t. Yt can be written as the function of only component, cyclical component and random component like this. Here covariance of epsilon I and epsilon j is equals to 0 for all I not equals to j. Variance of epsilon I should be equal to sigma square. Covariance between epsilon I and this sine 2 pi by lambda t should be equal to 0, and covariance between epsilon I into cos 2 pi by lambda into t should also be equals to 0. So these are the assumptions that we are taking for these models, which is again of econometrics. If you know econometrics, if you have done the lectures of the econometrics, then you will understand them better. So if you haven't, then I would suggest you to first do that portion first and then return back to this lecture video. So this is our time series model. Now we'll consider two functions, capital A and capital B. Let capital A is equals to 2 by n summation t goes from 1 to n sine 2 pi by lambda into t, and capital B equals to we'll take A as cos 2 pi by mu into t. Yes. And B would be 2 by n summation t goes from 1 to n sine 2 pi by mu into t, where mu can be represented as, where mu is an arbitrary constant and can be represented as mu square is equals to small a square plus, mu square is equals to capital A square plus capital B square. Now we can write A. Here also it will come yt in both yt. Now considering A. Capital A is equals to 2 by n summation t goes from 1 to n yt cos 2 pi by mu into t. Now replacing yt from this equation. Let us keep this as equation number 1. So replacing yt from here, we will be getting 2 by n summation t goes from 1 to n a sine 2 pi by lambda into t plus epsilon t into cos 2 pi by mu into t. Now epsilon terms will get cancelled, so we are only left with A is equals to 2 by n summation t goes from 1 to n A sine 2 pi by lambda into t cos 2 pi by mu into t. So let us consider that 2 pi by lambda is equals to alpha and 2 pi by mu is equals to beta. And replacing 2, also we'll take a outside and 2 inside. So this would be a upon n summation t goes from 1 to n 2 sine alpha t cos beta t. 2 sine A cos B will give us sine A plus B plus sine A minus B. This is a trigonometric ratio property. If you don't know this, then revise your basic concepts first and return back here. This formula I'm telling you, 2 sine A cos B would be sine A cos sine A plus B plus sine A minus B. So this would be A by n summation t goes from 1 to n sine A plus B plus sine A minus B into t. Now let us consider this as S1 and this as S2. So we have to find the summation also. This can be written as summation of this plus A by n summation t goes from 1 to n sine a alpha minus beta t, and this is nothing but S2. So these are two quantities that we have to find summation of and then answer. So summation of alpha plus beta into t can be taken as taking S1. S1 is summation t goes from 1 to n sine alpha plus beta into t. So if we solve this, first of all, we'll multiply by S1 into sine alpha plus beta upon 2 on the LHS and the RHS, and dividing and multiplying by 2. 1 upon 2 summation t goes from 1 to n sine alpha plus beta t into 2 also sine alpha plus beta upon 2. So 2 sine alpha plus into 2 sine alpha plus beta into 2 into sine alpha plus beta upon 2 will give us cos a plus b cos a minus b. So this will become a series of cos which would open as cos alpha plus beta minus alpha plus beta by 2 minus 3 alpha plus beta by 2. Then again cos, the next term would be cos 3 alpha plus beta by 2 minus 5 alpha plus beta by 2, and up till the last term would be cos 2n plus 1 2n minus 1 alpha plus beta by 2 minus 2n plus 1 alpha plus beta by 2. So these common terms will get cancelled and we are only left with first and the last term. Cos alpha plus beta by 2 minus cos 2n plus 1 alpha plus beta by 2. So this would be S1 into sine alpha plus beta by 2, which would give us 1 upon 2 into cos alpha plus beta by 2 minus cos 2n plus 1 alpha plus beta by 2. Cos A minus cos B would be sine n plus 1 into alpha plus beta by 2 sine n into alpha plus beta by 2. So these are the two values that we have got. Now the value of S1 would be sine n plus 1 into alpha plus beta by 2 sine n alpha plus beta by 2 upon sine alpha plus beta by 2. So this is the value of S1, and similarly in this way we can calculate the value of S2. So S2 would be, S2 was summation of t goes from 1 to n sine alpha minus beta by 2. So wherever there are sine alpha plus beta, we just have to replace the sign minus. So it would be sine n plus 1 into alpha minus beta by 2 sine n alpha minus beta by 2 upon sine alpha minus beta by 2. So this is the value of S2. When we sum both of them, we'll get the value of our YT. And if now we'll refer to for large n. If this now the result is for large n, if alpha is not equals to beta, then if alpha is not equals to beta, then A goes to 0. And if alpha reaches to beta, then A goes to A sine n plus 1 alpha plus beta by 2. And similarly for B, if alpha is not equals to beta, then B goes to 0. And if alpha reaches to beta, then B reaches to A sine n plus 1 alpha minus beta upon 2. So these would be the result, and it forms the basis of periodogram. So we'll discuss about periodogram and how does it leads to that in the next lecture. Till then, whatever we have learned in today's class, I know it was a bit, we have to mug up all of these. The research papers which include these kind of topics are very complex. So I have just told you the main portions. So you can do it with them. If you still have any doubt, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. So keep on working hard. All the best. Thank you.